Hi my dear students, welcome to Chemistry SR, our chemistry channel. In this video, we are going to discuss about chemical equilibrium. Intermediate first year, the chapter name is Chemical Equilibrium. Okay. Before entering into the chapter, we have to know few definitions. Then see what are they. First one, reactant. The second one, product. Okay? What is meant by reactant? Reactant is nothing but the substances which participate in a chemical reaction are called reactants. So, the substances which enter into a chemical reaction are the substance which participate in a chemical reaction. The substance which enter into a chemical reaction is called reactant. Okay. Then what is product? A product is nothing but the substance which forms during a chemical reaction. So simply the substance that formed during a chemical reaction, which is called a product. Okay. Then what chemical reaction tells? A chemical reaction tells everything about a reaction except the time of completion. How much time will it take to complete doesn't explain the chemical reaction. It tells everything except that. So, a chemical reaction tells everything about a reaction except the time of completion. How much time is required to complete the reaction? Okay, na? Such thing cannot be explained by a chemical reaction. Okay, that's it. Now we have to observe the types of chemical reaction. Generally, chemical reactions are two types. So, types of chemical reactions. Okay, types of chemical reactions. Generally, chemical reactions are considered as two types. Two types of chemical reactions are there. Number one, irreversible reactions. These are first type. Okay, na? So simply we can say generally two types. First one, irreversible reaction. What is meant by irreverse? No reverse. Once a product is formed, the reaction doesn't proceed back, doesn't give reactants back. Such reactions are called irreversible reactions. So, irreversible reactions are nothing but simply we can say one directional or unidirectional reactions. One directional or unidirectional reactions, nothing but which takes place in only one direction, nothing but forward direction, nothing but here only forward reaction takes place. So in irreversible reaction, only forward direction takes place. Nothing but here reactants converts into products. That's it. They never give reactants back. Okay. Such reactions are called unidirectional or one directional reactions. Here only forward reaction takes place. Okay. Here we have to take some examples for this irreversible reaction. Some examples. Then we get clarity. First type. Thermal decomposition reactions. Thermal decomposition reactions. What are thermal decomposition reactions? Thermal means heat energy. A decomposition of substances takes place by supplying heat. Such chemical reactions are called thermal decomposition reactions. For example, potassium chlorate KClO3, which on heating give potassium chloride and oxygen. 3 oxygens, 2 oxygen. We have to balance it. 3 here, 2 here. So we get 2 KCl. Here a potassium chlorate, a solid, which on thermal decomposition to give potassium chloride and dioxygen. So a solid decomposes to potassium chloride and a gas oxygen. Here the potassium chloride decomposed by supplying heat energy, hence it is called thermal decomposition. Next, calcium carbonate CaCO3, another solid, which is also on thermal decomposition to give quicklime, a solid, and carbon dioxide, a gas. So another thermal decomposition. In these two reactions, the products never recombine to give reactants. So when products are formed, the reaction stops. That's why called as irreverse, one directional reaction. First example. Example 1, thermal decomposition. Okay. Next, second type. Second type for thermal decomposition, precipitation reaction. If during a chemical reaction a solid component is formed, nothing but a precipitate is formed, then they never comes back to give reactant. Such reactions are called irreversible reactions. So precipitation reactions are also comes under precipitate reactions are also comes under irreversible reaction. See one example, precipitation reaction. Sodium chloride, a solution, an aqueous solution. To this silver nitrate solution is added, an aqueous solution. Silver nitrate crystals dissolves in water, we get silver nitrate solution. Similarly, sodium chloride crystals dissolves in water, we get sodium chloride solution. When these two solutions are mixed, instantaneously we get silver chloride, a curdy white precipitate, and sodium nitrate, an aqueous solution, a solid deposits. That's it. Here the formed AgCl precipitate never dissolves to give the reactants. Nothing but once silver chloride is formed, the reaction stops. Here for precipitation reaction, one more example, sulfuric acid, a solution, to this barium chloride solution is added. Sulfuric acid, barium chloride, an aqueous solution. We get a white precipitate of barium sulfate, okay, and then HCl, a solid deposits a white precipitate. So this precipitate doesn't give back to the reactant. So these are also example for irreversible reactions. Okay. Next see third one, neutralization reactions. neutralization reactions. What is meant by neutralization? An acid combines with a give base to give salt and water. Okay, such reaction is called neutralization. For example, hydrochloric acid HCl, a liquid, combines with sodium hydroxide, an aqueous solution. We get NaCl, a salt, and water is formed. Water is a liquid. In this neutralization, the formed sodium chloride and water never give HCl and NaOH back. That's why an example of irreversible reaction. So, thermal decomposition, precipitation, neutralization reactions are best example for irreversible reactions. Okay? Unidirectional, one directional. Okay? Clear? That's it. Next, second type, reversible reactions. Next, second type, reversible reactions. What are reversible reactions? A reversible reaction is one in which both the forward and backward reactions takes place. Okay? So, reversible reaction is nothing but in which both forward and backward reactions takes place. Nothing but reactants converts to product, at the same time the products give back to the reactant. Such reactions are called reversible reactions. Okay, two directional reactions. Two directional reactions. Nothing but initially reactants converts to products. When some amount of product is formed, they give back to the reactant. That's why they are called as reversible. Nothing but both forward and backward reactions takes place. Reactants converts into products is called forward. Products giving reactants is called backward. In reversible reactions, both forward and backward takes place. Okay? Most of the reversible reactions takes place in a closed vessel. So, most of the reversible reactions takes place in a closed vessel. Mostly they takes place in a closed vessel. Clear? Okay. Actually, a reversible reaction never goes to completion. Never completes, because forward reaction and then products come back to the reactant. Reactant converts to product, product give the reactants again. So the reaction never goes to completion. So a reversible reaction never goes to completion. But a forward reaction is completes when one of the products removes from the mixture. The reaction completes when one of the product removes from the mixture. Okay, na? The forward reaction completes when one of the product removes from the mixture. Okay, otherwise never goes to completion. Okay, if one of the product removes, the forward reactant completely converts to product, they doesn't give reactant back because the product is removed. So completely reactants gives the product and stops. So that the reaction completes when one of the product removes. Clear? Okay. Here in a reversible reaction, the state at which both the forward and backward reactions takes place with the same speed. Before that, we have to observe some examples. Let's see some examples for reversible reaction. Some examples. For example, hydrogen gas combines with iodine gas, they give hydrogen iodide, which further dissociates to give hydrogen and iodine. Okay. Similarly, nitrogen gas combines with oxygen gas to give nitrogen monoxide gas, another reversible reaction. Similarly, phosphorus pentachloride, which decomposes to give phosphorus trichloride gas and chlorine gas. Okay. One more example. Nitrogen gas combines with hydrogen gas to give ammonia gas. Okay. Examples for reversible reactions. Next, NO2 gas dimerizes to give N2O4 gas. Okay, another reversible reaction. All these are gas phase reactions. Let's see the liquid phase reactions. Acetic acid, a liquid, combines with ethyl alcohol C2H5OH, another liquid, we get an ester, ethyl acetate, CH3COO C2H5 and water. Okay. Here acetic acid, alcohol are in liquid state, ester and water are in liquid state. Liquid phase reaction, a reversible reaction. Next is solid phase. Calcium carbonate, a solid which decomposes to give calcium oxide, another solid, and carbon dioxide gas. If the vessel is a open vessel, remember, if the vessel is a open vessel, the CO2 gas escapes out, there is no reversible. If the vessel is a closed vessel, CO2 gas never escapes from the vessel. So the products recombine to give the reactant calcium carbonate. So these are the examples for reversible reactions. Okay, let us consider a reaction. For example, A combines with B to give C and D. Then the products recombine to give the reactants A and B. So observe clearly. Initially in a vessel we take A and B, nothing but only reactant. When the time t is equals to 0, A and B are predominant. Nothing but only reactants are present in a vessel. There is no products. So as the time progresses, the reactants A and B combines to give products C and D slowly. Okay, I mean some amount of products starts forming. Only reactants are present. As the time progresses, the product concentration slowly increases because they are formed during a chemical phenomena, chemical process. But the concentration of reactants decreases. After some time, the speed of the forward reaction decreases because reactant concentration decreases. But the speed of backward reaction increases because product's concentration slowly increases with time. And after certain time, the speed of forward and the speed of backward both are equal. Then that state is called equilibrium state. The state at which both the forward and backward reactions takes place with the same speed is called equilibrium state. So initially forward reaction takes place fastly. After some time backward reaction starts, and later on both the forward and backward reactions takes place with the same speed. Such a state is called equilibrium state. So the state at which both the forward and backward reactions takes place with same speed, nothing but same rate, is called equilibrium state. Okay, is called equilibrium state. Okay, done. Next thing, the equilibrium will be established in a reversible reaction. The reversible reaction may be a physical process or chemical reaction. So equilibrium state is nothing but the state at which both the forward and backward reactions takes place with the same speed. Clear? Okay. Equilibrium will establish. Equilibrium will establish in both physical processes or in a chemical reaction. An equilibrium will establish in both physical process or in a chemical reaction. That's it. So see some examples for physical phenomena. So physical processes. Let us take some examples to understand the existence of equilibrium in physical phenomena. The first one, a solid converts to liquid, which on further converting into a solid, freezes to a solid. This process is called melting. So the forward process, so solid converts to liquid, is called melting or fission. Melting process or fusion. Example for this process is ice converts to water. Ice converts to water, which then solidifies to ice, nothing but freezes to ice. An example for solid liquid equilibrium. If the equilibrium may be between a liquid and a gas, when a liquid converts into gas, the process is said to be evaporation. So evaporation or vaporization. Simply H2O, liquid, nothing but water, vaporizes to steam, water in gaseous state. So water and steam equilibrium is an example of liquid gas equilibrium. Next, a solid directly converts into gaseous state. Solid gas equilibrium. This process is said to be sublimation. When a solid directly converts into gaseous state, then the process is said to be sublimation. For this, camphor converts into camphor in gaseous state. Solid evaporates, vaporizes when you kept in air. Okay. Similarly, iodine, a solid, evaporates to give a gaseous iodine. Similarly, ammonium chloride, a solid, which sublimes to give ammonium chloride, a gas. So these are the examples for sublimation. Okay, nothing but all these are example for reversible processes, nothing but existence of equilibrium in physical processes. In these physical changes, there will be an equilibrium will exist. Okay, now come to chemical process or a chemical reaction. Chemical reaction. See how an equilibrium will exist. For example, let us take a chemical reaction like N2 gas combines with a hydrogen gas to give ammonia gas. Okay, nitrogen combines with hydrogen to give ammonia gas. A chemical change, a chemical phenomena, a chemical reaction, reversible, so equilibrium will exist. So see a graph. Initially, if you take time along x direction, time is taken along x direction, concentration of reactants and products taken along y direction. So time along x, concentration along y. Initially, in a reaction vessel, only reactants are present. Nothing but when the time t is equal to 0, the concentration of reactants is predominant because only reactants are present. Nothing but reaction starts now. Okay. So reactant concentration is high. Time t0, concentration is very high. Okay. As the time progresses, the concentration decreases like this. So this is for forward reaction. For forward reaction. Similarly, initially there is no products, right? Because reaction just starts. No product is formed yet. So at a time t is equal to 0, the product concentration is 0. But as the time progresses, slowly product starts forming, nothing but their concentration increases. Concentration of products increases. After some time, the concentration of reactants become constant. Similarly, the concentration of products increases. After some time, their concentration remains constant. So this is for backward reaction. Here the state at which or the time or the state at which concentrations of reactants, concentrations of products remains constant, then that state is said to be equilibrium state. Clear? Once equilibrium is established, there is no change in the concentration of reactants or products. Why? Because at equilibrium state, forward reaction and backward reaction takes place with the same speed. It means amount of reactants converting into product are exactly equal to amount of product formed from the products. Number of reactant consumed, number of reactant formed are equal. Similarly, number of product formed, number of product consumed are equal. So, their concentrations remains constant at equilibrium. Suppose, if you take time along x direction and rate nothing but speed along y direction. When time t is equal to 0, the vessel contain only reactants, right? So the forward reaction takes place vigorously because only reactants are present. So they readily converts to products. So the forward reaction takes place vigorously. Nothing but forward reaction speed is very high forward. Okay. But as the time progress, the rate of the forward reaction decreases. Why rate decreases? Because reactant slowly converting into products. So concentration of reactant decreases. So forward reaction speed also decreases. But at the same time, initially product concentration 0, so the backward reaction speed is 0. But as the time progress, some amount of products starts forming. When some amount of product is formed, backward reaction starts. Okay, as the time progress, the product concentration increases so that backward speed increases. So as the time progress, backward reaction, nothing but rate of the backward reaction increases. But at a certain time, product forward speed decreases, backward speed increases, both reaches an equilibrium. Both remains constant, both remains same. Both remain same. At a state at which both the forward and backward reactions takes place with the same speed or same rate, then that state is called equilibrium state. Okay, and mostly equilibrium is established in a closed vessel. Equilibrium is established in a closed vessel. The second thing, both forward and backward takes place with the same speed. The equilibrium is established at a constant temperature. Equilibrium is established at constant temperature. Okay, this is about introduction of chapter. Nothing but reaction, reversible reaction, irreversible reaction. Okay, examples for reversible, irreversible. A reversible reaction is nothing but two directional reaction in which there is an equilibrium will establish. An equilibrium is nothing but the state at which both of the forward and backward takes place with the same speed. And the equilibrium may be exist in physical phenomena and chemical reaction. Examples for physical processes and example for chemical reaction. What happens at equilibrium? Concentrations of reactants and products remains constant. They may or may not equal, but rates are equal. Both forward and backward takes place with same rate. Okay, I hope you understand. Keep watching, but don't forget to like and share to someone. Thank you.